Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and this particular question belongs to paper 9709/45 for the session May June 25. Let's see what the question number 6 says. A particle P moves in a straight line starting from a point O. At time t second after leaving O, the velocity v meter per second of P is given by v is equal to 15 minus 2t whole squared. Find the values of t when the velocity of P is 100 meter per second. So it's one of the simplest and easiest of all questions. Let's start the solution. The expression of v is v is equal to 15 minus 2t whole squared. Then they have told us to find when velocity is 100. So we can write 15 minus 2t whole squared is equal to 100. If we transpose the square to the other side, it is going to be square root over 100 means positive negative 10. Okay. Or minus 2t is equal to negative 15 plus minus 10. Or if we discard this negative symbol from each of the sides, it is going to be, or 2t is equal to 15 plus minus 10. Now look at this. If we use the positive symbol, 15 plus 10 is equal to 25. If we divide 25 by 2, it is going to be, so our t is going to be 25 divided by 2, so 12.5. Let us take the smaller value first. If we subtract 10 from 15, it is going to be 5. If 5 is divided by 2, it is going to be 2.5, or the second value is going to be 12.5 seconds. So these are the two values of t. Let's see what the next question says. The next question is, show that there is a particular value of t for which the velocity and acceleration of the particle are both zero. So first of all, velocity is 0, v is equal to 0, and we know that v is 15 minus 2t whole squared is equal to 0. That means our 15 minus 2t is equal to 0. Hence our t is going to be 15 over 2 means 7.5. So when at 7.5 second the velocity was 0, then they have told us to find the acceleration at the same time was also 0. So let's find the acceleration. For acceleration, we will find the derivative of velocity. So v is what? 15 minus 2t whole squared. Well, if we differentiate both sides, it is going to be dv in terms of t equal to 2. Then if we differentiate the inner part, it is going to be negative 2. So negative 2 into negative 2, then 15 minus 2t, inner function is going to be same and exponent is going to be 1 instead of 2. After that, so dv over dt, that means derivative of v in terms of t is acceleration. So we are going to find the acceleration. Hence acceleration is equal to negative 4 into 15 minus 2t. Now let's go back to the condition. What was the Condition was that acceleration of the particle are acceleration and velocity was 0. So a is equal to 0. Let us write. I can write just beside this, drawing a line segment. Yes. So a equal to 0. A equal to 0 when a, we have already obtained our a is negative 4 into, I can show you whole of the part, it is negative 4 into 15 minus 2t. Negative 4 into 15 minus 2t is equal to 0. That means 15 minus 2t is equal to 0. Hence, if we make t as subject, it is going to be 7.5. So what did we get? For both acceleration and velocity 0 at the time when t is equal to 7.5. So they have told us to find the value of t. Hence, t is equal to 7.5 seconds in both cases. Okay. That's all about the answer to this question. Let's move on to the question number C. Question number C is on the next page. Let's see what it is. Question number C says, find the displacement of P from O at the time that the velocity and acceleration of the particle are both 0. So it's all about displacement. Well, for displacement, we know the integrand of velocity is the displacement. Before that, we can draw a graph to understand the scenario. So let me draw the graph over here. Okay, this is velocity and it is time, velocity against time is 0, and our v meter per second is the vertical line. Okay, then let us see the velocity was what? V is equal to 15 minus 2t whole squared, isn't it? Well, let's find the constant value of velocity when t is 0. V is going to be 15 square, means 225. So at the beginning it is 225, 225, 225. Okay, then as this is quadratic graph, it will move from the second quadrant, and let's see when does it cross the horizontal axis. We have already learned from the previous question. Look at this. When t was 7.5, when t was 7.5, the stationary point, I mean acceleration was 0. At the same time, velocity was also 0. So we will have to write that 7.5, 7.5 over here. Let's see. Let me write over here. This is 7.5. Suppose here 7.5. 7.5 is over here. Then the curve will look like this way. Okay. Let me try to draw one more graph. Yes, it may make sense. So this is our graph. Okay, now we will have to find the displacement. Okay, so v is equal to this. If v is this, then we will integrate both sides. If we integrate from 0 until 7.5 seconds. Okay, 0 until 7.5 second, we are going to integrate v in terms of t is equal to, going to be, it will be 1 over 3, because if we integrate, the exponent will increase by 1, so it is 3. And if we differentiate this, it is negative 2, so negative 2. And what will happen to the function? The inner function is going to be 15 minus 2t, and the exponent is going to be 3. Well, so this is our expression, and the limit is from 0 until 7.5 second. Okay, then if we integrate velocity, we know this is nothing but displacement. So let us write displacement means s. S is equal to negative 1. I think this space is not sufficient. Let me say, yes, I can go downward. So it is going to be S is equal to, or S is, S is, S shows the displacement. S is equal to negative 1 over 6, then 15 minus 2t raised to 3, and the limit is from 0 until 7.5. Okay, then let's see whether it will show a positive value or not. If we look at the graph, actually our displacement is this portion. Okay, this portion is our displacement, this portion. This black shaded part is our displacement. Okay, we are going to find the area of this shaded black shaded dark part. This is our area, and if we notice, we will find that this is above x-axis, so surely it will produce positive value. We are going to obtain a positive value of this area. So let's see what is that area. Okay, then it is going to be, or s is equal to negative 1 over 6, negative 1 over 6, and 15 when it is 7.5. Look at this, when t is equal to 7.5, it is going to be 15, so 15 minus 15 is 0. Then minus, if t is equal to 0, the lower limit, then it is going to be 15 minus 0 means 15, so it is 15 cube, and 15 cube means actually 3375. 3375. Now if we simplify more, we will get, or s is equal to, and negative negative, it is going to be positive, so it is 3375. 3375 over 6. Let us do the division. After dividing this, our displacement is going to be 6 5 30, so 6 5 again 30, no, 6 6 36, so it is 6, then 15, 15 means 2.5. So this is the distance traveled by the particle starting from 0 until 7.5 second. So this is what the solution to the question of C, and as I have told, it's one of the easiest and simplest of all questions of this paper. So let's go back to the first question. This was the first two solutions, and then in the first two solutions also they are not difficult at all, and so is the third one. And I think you have got my points as I have clarified. It's actually velocity is given, and from velocity, if we want to find the displacement, then it's nothing but integration. So we have integrated the velocity expression. And remember, you may ask a question about why isn't there any constant value. Look at this. So if you are confused with this constant value, let's see the graph. When t was 0, look at this, when t was 0 at the time of beginning, there was no displacement at all. I mean, displacement was also zero. Okay, displacement starts from the vertical line to this direction, vertical line to the positive direction of x. Okay, so at the beginning it was on the vertical axis, so there is no uh, displacement at all at the beginning. That's why there should not be any constant value. I think you got my point. So thank you all for being with me, and may Allah bless all of us with the beneficial knowledge that will make the whole humankind knowledgeable, sincere, honest, and devoted to the Almighty Allah. Fi amanillah.